Hello friends, welcome to kodEdge. In this session, we will see how to monitor microservice using Prometheus and Grafana. So this is what we are going to build at the end of this session. So these are the topics we are going to cover in today's session. So first we will understand the Prometheus architecture. After that, we will understand the types of metrics. Then we will understand the individual metrics with the help of example. After that, we will jump on the hands-on. In the hands-on, we will first create a Spring Boot application. In the Spring Boot application, we will create a simple REST APIs. After that, we will configure custom metrics for the REST APIs, and we will send the metrics to the Prometheus server. Then we will set up Prometheus and Grafana, and after that, we will create a dashboard in Grafana to see the metrics sent by our application. So note that if you are already aware of these basics, then you can skip the basic part of this session and directly jump on the hands-on section. Now let's understand the architecture of Prometheus. So Prometheus is an open source monitoring and alerting toolkit, and it follows pull-based model for collecting the metrics. So this is a Prometheus server. This is a central component responsible for collecting and storing the time series data, that is metrics. So it periodically scraps the metrics endpoints from the configured targets, and targets are like application, services, or infrastructure components. So what is the meaning of scrapping? Scrapping means it is a process of periodically fetching or collecting the metrics from the target, and target exposes their metrics via specific endpoints. So Prometheus server also provide a query language, which is also called as a PromQL, for querying and aggregating the metrics. So as you see in the diagram, Prometheus server has a three component. The first component is a data retrieval worker. So it scraps and collects metrics from the application and from the short-lived jobs, and it then converts the metrics into time series data and store that metrics into its local time series database. So time series database is a storage system within the Prometheus server that store time series data, that is metrics. So metrics are stored with the labels like key value pair to enable efficient querying and the filtering. Next is the HTTP server, which responds to requests and PromQL queries for the time series data. It then presents the information in the web user interface or a dashboard. So it can either use a third-party platform like Grafana or inbuilt Prometheus web UI. So Grafana is not part of Prometheus, but Grafana is often used with the Prometheus for visualization and dashboarding purpose. So Grafana connects to the Prometheus using data source and provide user-friendly interface for creating a dashboards. And we are going to see this in our hands-on. So there is one more component which is called as a push gateway. So short-lived jobs or batch processes push metrics to the push gateway, and then data retrieval component will pull the metrics from the push gateway. And next component is a alert manager. So this is also a separate component responsible for handling alerts generated by Prometheus. So alert manager configures alerting rules and routes alerts to the appropriate receivers like email or Slack based on the defined routing rules. So Prometheus offers 4 core metrics types. So first is a counter, second is a gauge, third is a histogram, and last one is a summary. Now let's understand all the metrics individually. So let's start with the counter metrics. So counter metrics type is used for any value that only get increases, such as a request count, error count, or any other discrete events. So when to use counter metrics? So let's say you want to monitor the values that only goes up, or you want to query how fast the value is increasing. And these are the use cases in which you can use the counter metrics. Let's say you want to measure the frequency of events in your application over a time, or you want to monitor the number of requests or errors, or you want to count number of messages processed by your application, and so on. So this is the example of Prometheus query for the counter metrics. In this example, we are using a sum. So this query calculates the total number of HTTP requests over a time. Also note that do not use counter to expose a value that can get decreases. For example, do not use counter metrics for the number of currently running processes. For that, you can use gauge metrics. So this is a sample of counter metrics sent by application. So Prometheus metrics include help text and matrix type to provide the additional information about the matrix. So here help, which describe the purpose of associated matrix. Then it has a type which specify the type of matrix. Then this is a visit counter, which is the name of the matrix, and 23 is the actual matrix data, that is total visit count. Now let's understand the gauge matrix. So gauge matrix that represent the single numerical value that can go up or down, right? So when to use gauge matrix? So when you want to monitor values that goes up or down, or you want to measure the instantaneous value of particular attribute or a state in your application. And these are the use cases in which you can use the gauge matrix. For example, you want to represent the current state of your resource utilization of your application, which allow you to track the health of your application. Then you want to track the number of active threads, or you want to monitor the size of queues or job queues, and so on. So this is an example of Prometheus query for the gauge matrix. So this query retrieves the current value of HTTP request duration. So this is a sample of gauge matrix which is sent by our application. So here it has a help which describes the matrix. Then it has a type which is of the type gauge. Then this is a matrix name, that is a queue size, and the actual value of the queue size, that is 25. Now let's understand the next matrix, that is histogram. So histogram divides the observed values into configurable buckets. So it also provides the sum of all the observed values. And by default, this is how the buckets look like. So histogram group value into buckets and count the occurrence in each buckets, providing the histogram distribution. And Prometheus calculates quantiles, which is also called as percentiles, from the bucket value. So let's understand when to use histogram. So when you want to measure the distribution of observed values, typically for the metrics like response times or any continuous variable. And these are the use cases in which you can use the histogram metrics. Let's say you want to measure the duration of your API responses or a service call, or you want to track the duration of background task for a job execution, or you want to measure the time taken for the database query to execute, and so on. And this is an example of Prometheus query for the histogram matrix. So this query retrieves the bucket count for the HTTP request duration. So this is a sample of histogram matrix sent by our application. So this is the name of the histogram matrix. These are the labels represent the application or service name associated with the matrix. Then this is a bucket label. So this label represents the upper inclusive boundary of the histogram bucket. So this LE label indicates less than or equals, and it specifies the upper bound of the bucket. This represents the count or frequency of observation that fall into that specific bucket. So in this case, it indicates that there were 21 HTTP requests with the duration less than or equal to upper inclusive boundary specified in that bucket. So as a summary, this matrix represents the count of observation falling into different buckets based on the HTTP request durations. And the last metric is summary matrix. So it is similar to histogram matrix. Only the key difference between them is with the histogram, quantiles are calculated on the Prometheus server using histogram quantiles functions. And with the summaries, they are calculated on the client side and exposes them directly to the Prometheus server. And when using summaries, you get the benefit of aggregated statistics without having to decide on bucket boundaries. So when to use summaries? So when you want statistics such as a mean, max, and percentiles without explicitly defining the buckets. And the use cases are almost similar to the histogram use cases. And this is an example of Prometheus query. So this query retrieves the mean, max, and other statistics for the HTTP request durations. And this is a sample matrix sent by our application. So you can see quantiles, count, and sum in the sample. So do not worry about it. We are going to see all this configuration in our hands-on. So let's move on to the hands-on. So first we will create a Spring Boot project using Spring Initializer. So our name will be Spring Monitoring Demo, and I'm giving the same name in the artifact as well. So build system I'm using as a Gradle, and JDK version will be 17. Now let's add dependency in our project. So first dependency will be for the REST APIs. Okay, so dependency will be Spring Web. Next dependency we will add for the Prometheus. So let's search for the Prometheus. Okay, so this will add dependency for the micrometer, and micrometer exposes the matrix in the Prometheus format. So let's add this dependency. And next dependency we will require for the actuator. So this support built-in endpoints that let you monitor and manage your application. So this dependency is required to expose our application metrics. Okay, so let's add this dependency as well. And let me generate this project and open it into the IntelliJ. Okay, so our project is initialized. So let's open the build.gradle file and let's remove this version. So we are not going to use any versioning for our jar. Next, let's review the dependencies that we have added. So first dependency we have added for the actuator. The next dependency for the REST APIs, that is Spring Boot Starter Web. And this is a micrometer dependency which will require to convert the metrics into the Prometheus format. Okay, now let's add the controller to test our metrics. So let me create a new class, and class name I am giving as a test controller. Okay, so test controller is created. So I have already code for the test controller. Let me copy that code. It will save some time. Okay, so let me explain this code. So what we are doing in this test controller. So let me collapse all the methods. So I have created the 4 API here, which are all the type of gate mapping. And in all the 4 APIs, we are going to create a custom matrix to monitor these REST APIs. Okay. Next, I have created one small function to get the random number, which we are going to use in these APIs. Now let's understand what I'm doing in this test controller. So first I have annotated this controller with the @test controller. Next I'm declaring the variables for the matrix. So first matrix I am declaring as a counter matrix. Next matrix I am declaring as a timer matrix. Then third one is a distribution summary, which we are going to use for the histogram. Next I am assigning the list with some predefined values, and I'm naming it as a queue, which we are going to in this APIs. Okay, and we are going to monitor this queue using the gauge matrix. So next I have created the constructor for the test controller, and in the constructor I am passing the meter registry as a parameter. So what is meter registry here? Meter registry act as a centralized registry for all the metrics in your application, and it keeps the track of all the metrics that you are going to create in your application. Okay, then I am initializing all the metrics in the constructor. So let's understand how to create the metrics now. So first matrix we have declared as a visit counter. Okay, so this is a type of counter matrix, and here I am using the builder for creating a counter matrix. So this is the name of the matrix, visit underscore counter. Then you can specify the tags, and this is a description for your matrix. So number of visits to this API. Then I am registering this matrix into the meter registry. Okay, simple. Next I am initializing the timer matrix. Again the same way I am using a builder, and this is the name of the timer matrix, that is a custom time recorder. Then these are the tags which are optional. Okay, description is also optional. Then description is time required for the API. And next I am registering this timer matrix into the meter registry. Then I am creating a gauge matrix here. So what I am passing to the builder, this is a queue size, this is the name of this gauge matrix. Then actual queue object here. So this is a queue we have created here, right? Then I am returning the queue dot size. So we want to monitor the size of this queue in the graphs. Now next I am creating the histogram matrix. So for this I am using the distribution summary class, and same way we are using the builder. This is the name of histogram matrix. Then this is the description. Then I am using publish percentile histogram. Okay, so we want to see all the histogram in the form of buckets. Then at the end I am registering this matrix into the meter registry. Okay, very simple, right? Next, we are creating the APIs, and in these APIs, we are going to use this metrics to monitor all these APIs. Okay, so these are very simple APIs I am creating for the demonstrating this metrics. So first API I have created as a visit API. So it will count the number of times that API called by the user. So what I'm doing here, I'm using the visit counter matrix that we have created here, and I'm just calling the increment method. Okay, so whenever this APIs get called, this counter will get incremented, and at the end I am just returning that count. Next API I am creating as a get response time. So in this matrix I am using a timer matrix. So first statement is I am starting the timer. Then I am doing some work. This is like sample work. So I am making this thread sleep for the some random number of time. Then next operation I am doing is I am removing some elements from the queue. If the queue size is greater than 0, in that case only it will remove the first element from the queue. Next I am recording this time, and at the end I am calculating the total duration it took to execute this operation. I am just recording that time. Okay, then I am converting this time into the millisecond format, and then I am just logging this time on the console and returning the total duration this API took to execute the operation. So this is example for the timer matrix. So next API to monitor the queue. So what I am doing in this API, I'm just getting a random number using get random number function, and I am adding that number into the queue. And when this API get called, it will return the size of the queue. And we have already created the gauge matrix for the queue. So it will return the matrix related to the queue size. Okay, for that purpose, I am creating this API. Next API I have created for the histogram matrix. So what I'm doing here, I'm doing the same thing that we did for the timer matrix. Okay, so what I'm doing here, I'm just getting a current time when this API get called. Then this API do some operation. For sample purpose, I'm just slipping the thread for some random number of seconds. Then I am getting the current time again after this operations complete. So I'm calculating the time difference between the start time and the end time between this operation. So it will calculate the duration it took to execute the operation. Then I am recording that duration into the histogram matrix, and I am just returning this duration from this API. Okay, so our custom metrics are ready. Now what we will do, we will require to add configuration for the actuator to expose all the metrics from our application. So let's go into the resources folder, and here we will create a resource.yaml file. So let me create a new file here. File name will be application.yaml, and let me copy code for this configuration. Okay, so this is the configuration for the actuator. So what I'm doing first, I'm just creating a name for our application. So this is the optional part. This part I'm using here, okay, in this tab. So I'm giving name for our application as a spring-prometheus-demo. Then this is the configuration for the actuator. So what this configuration will do, so if you see this exposure tag here, so what does this exposure tag will do? This exposure section is used to define which actuator endpoints are exposed over HTTP. Okay, and this include property specifies the list of actuator endpoints that should be get exposed from our application. So these are the two APIs we are going to expose from our application. Okay, so what is the health? So health endpoint provide the information related to the health of our application. And what is this Prometheus? This Prometheus exposes the custom metrics that we have just created in the format compatible with the Prometheus. Okay, and if you don't include this include tag here, in that case it will expose all the metrics from our application. Next, I am creating the metrics tag here, and here I am just giving the name of our application. Okay, so if you have not created this, you can directly give name of your application directly from this application tag. So actuator configuration is ready. Now what we will do next, we will run this application. So let me go into the main class and just click on this green button. Okay, so our application is started. So let me open the browser, and here we will run one URL. So let me write the URL. URL will be localhost:8080/actuator. So these are the endpoints we are exposing from our application for the monitoring purpose. So if you click individual API, let me copy this URL. So this will give you health related metrics. Okay, so it will give the up or down of your application status. So let me copy the next metrics, that is Prometheus. So let me copy this API. So this will return all the metrics related to the Prometheus in the format required by the Prometheus. So if you see, this is a help text which explains the metrics, and this is type of metrics. So you can see it is a type of gauge metrics. So these are the default metrics written by the actuator. So these are the custom metrics that we have created. So let me copy one of the tags that we have created here. Let's say we want to see the visit counter. Okay, so let me go into the browser and let's search for the visit counter. Okay, so this is the matrix we have created for the counter, right? So matrix type is a counter, and this is the actual value for the visit counter. So we have not called this API, that's why its value is 0.0. Then next matrix is, let's copy the name of the histogram matrix and search for it here. So this is a histogram matrix, and you can see all the buckets here, right? And in all the particular buckets, it has a certain particular value. You can see type of matrix as well. So this is a histogram matrix, right? Now next, what we will do, we will set up the Prometheus and Grafana. So for that, let's create a new project, and in the new project we will create a Docker Compose file and other configuration required for the Grafana and the Prometheus. So let me create a new project. So let's open the IntelliJ and click on the new project. So here we are going to create an empty project because we are not required any extra configuration. So you can manually also create a new folder and create a Docker Compose file in that folder. Okay, so I'm giving name as a apps-monitoring, and let's create this project. So let me open that project. Okay, in the app monitoring, now we are creating the configuration for the Grafana and the Prometheus. So before starting, just create this directory structure which required for the Prometheus. So first directory we are going to create for the Grafana, and in the Grafana, let's create a new directory. Directory name will be data sources. Okay, and in the data sources, we are going to create configuration for the Grafana to connect with the Prometheus. So configuration name will be, or the file name will be, let me create a new file. File name will be datasources.yaml. And here we are going to configure our data source for the Prometheus. Next, we will create a directory for the Prometheus. So let me create a new directory here. Directory name will be Prometheus. And in the Prometheus, we are going to create a new file. File name will be prometheus.yaml. Okay, so in this file, we are going to copy configuration for the monitoring our application. So let me copy the configuration. Okay, so what we are doing here, so let me explain this configuration. So here we are defining the scrap configuration. So using this configuration, Prometheus will find the service, or you can say it will discover the service in our local system. Okay, or you can say in a Docker. After finding that service, it will start monitoring that application. So here I am giving the job name. So job name will be my app metrics. Okay, so you can give any name to the job. Next, I am defining the path. So from which endpoint it will get the metrics, right? So this is the metrics path, and path will be /actuator/Prometheus. Next is a scrap interval. So what is the meaning of scrap interval? So every 5 seconds, it will pull the metrics from our application. Okay, so you can configure as per your requirement. Next is a static configuration. So what we are doing here, we are mentioning the target URL. So we are exposing our application on the host.docker.internal. Okay, so this is a local host, but in the Docker you can specify URL like this, and port will be 8080, and this is the name of our application. Now in case you have multiple application on your Docker, so you can specify the multiple jobs like this, and here will be different name for your application. So you can specify multiple scrap configuration for multiple applications. So currently we have only one application, so we are going to specify only one scrap configuration. So let me remove this. Okay, so our Prometheus configuration is ready. Next we will create a Docker Compose file. So let me create a new file here. File name will be docker-compose.yaml, and let me copy a configuration for it. Okay, so what we are doing here, so let me explain that thing. So first, this is the version for the Docker Compose. Next, I am defining the two services. First service will be Prometheus, and second service will be Grafana. Now let's understand each service. So in the Prometheus section, what we are doing, this is the name of the service, that is a Prometheus. Then I am pulling the image from the Docker Hub. So let me remove this version. So it will automatically pull the latest version. This is a container name for the service. Then this is a port. So Prometheus we are going to expose on the 9090 port. Then this is volume configuration. Okay, so what I'm doing here, I'm just copying this prometheus.yaml file from this Prometheus directory into this particular path of the volume. Next, I am defining the Grafana service. So here as well, I am pulling the Grafana image. So let me remove this version. So it will pull the latest image automatically. Then this is the name for the container. Then I'm exposing Grafana on the 3000 port. And this is a restart policy for the Grafana. And this is a volume configuration. Okay. Now let's create a configuration into data source. So let me copy configuration for the data source. So what is the purpose of this configuration, right? So what it will do, in the Grafana dashboard, you are required to get the metrics from the Prometheus, right? And for that purpose, you will require to connect to the Prometheus. And this is the connection configuration for the Grafana and the Prometheus. So what I'm defining here, I'm defining the data source. So type will be of the type Prometheus. Then I'm providing the proxy as access. And this is a URL for our Prometheus. And from where this Prometheus name coming from? This name coming from this service name. Then this is a port of our Prometheus, that is 9090. Okay, and this will be our default data source configuration in the Grafana. So this is completely optional configuration. If you don't define this configuration, in that case you will have to do manual configuration in the Grafana. Now what we will do next, we will set up Grafana and Prometheus in the Docker. So let me open the new terminal. So before that, let me stop our application that we have already started. Okay, so let's stop this application for now. And let's open the terminal. So let's go into our project directory, that is app monitoring. And I have already started Docker on my local machine. So before running the Docker Compose command, make sure that you have already started the Docker on your machine. So here I am running command as a sudo docker-compose and up. So this sudo part is optional. So on my machine, when I run the Docker Compose command, normally I am getting issue with the etc folder, that is permission denied issue for the etc folder. In your case, if you are not getting any issue, you can run the command like docker-compose.yaml. Sudo is optional part for you. Okay, so let's execute this command. So let me give the password. It will pull the image for the Grafana and the Prometheus, and it will take some time to download the image. Okay, so our Prometheus and Grafana both are started in the Docker. So let me open the browser, and URL for the Prometheus will be localhost:9090. Okay, so this is a Prometheus web UI for monitoring the metrics. So next, what we are going to do, we are also dockerize our Spring Boot application, and we will deploy this application into the Docker container. So let me open the IntelliJ. Okay, so dockerize our application. What we will do, we will add the configuration for the Docker. So let me create a new file. File name will be Docker file. Okay, so let me copy the configuration for it. So what we are doing here, we are using the parent image as a OpenJDK:17. Then we are exposing our application on port 8080. Next, I am copying the jar. So our jar will get created into the libs folder inside the build folder. Then I am copying this jar into the Docker. And this is command to execute our jar. So very simple configuration. Okay. Now what we will do, we will first build our project. So command will be /gradlew clean build. Okay, so build is successful. Now if you see in the build folder, in the libs, our jar is created. So next what I will do, we will dockerize this application in the Docker container. So let me open the new terminal. So here, let me go into the project directory. So command will be docker build -t, then name for the application or tag. So I'm giving the same name as a application name. And at the end, don't forget to add dot. Let's execute this command. So it is building the image for our application. Okay, so it has created the image for our application, and let's run our application. So command will be docker run -p and our port on which we are exposing our application. So that will be 8080 and name of the image. So name that we have given as a spring-monitoring-demo. And let's execute this command. Okay, so our application is started in the Docker. So next, let me open the browser. Let's refresh this Prometheus web UI. Now click on this button here, and you can see all the metrics sent from our application. Now if you want to see if this monitoring our application, what you can do, click on the status and click on the service discovery option here. And you can see this is the name of our application, which this Prometheus is monitoring. And if you want to see target as well, in the target you can see on this URL, this Prometheus is monitoring our application. Now click on the graph, and if you click here, we will see all the metrics which are exposed from our application. Okay, so these are the metrics that we have created in the REST controller, that is visit counter. Now next what we will do, we will call the APIs that we have created into the REST controller to see some metrics in this Prometheus web UI. So let me open the IntelliJ. So let me go into the controller, and let's call this all this API. So our first API is visit API. So let me copy this name, and let's execute this API. So URL will be localhost:8080/API name. Okay, so API call for the first time. Let's call this API for multiple times. Now, if you want to see the metrics, what you can do, just go into the Prometheus, just copy name of your metrics, that is visit counter, and let's go into the Prometheus UI, click on this metrics explorer option here, and search that metrics here. So this is the metrics we are getting from the application. So visit counter underscore total, and click on the execute. Okay, so this is the metrics that we are getting from our application. And if you click on the graphs, and let's reduce this time here, let's make it to the 5 minutes. Okay, so you can see graph as created by the Prometheus. Now let's execute others API as well. So let me copy the name of the APIs. So next API is get response time. Let's execute this API. So this is returning the time it took for the executing the operation. Okay, so let me call this API for the multiple times. So same way we are going to call other API as well. So let me copy the next API, that is the queue size. Let's execute. So queue size is 16 now. Okay. Next API is histogram. So let's call this API for multiple time. So this is also returning the total time it took for the execution. Now what we will do, we will see the histogram metrics in our Prometheus web UI. So copy this tag here. And let's go into the Prometheus web UI. Click on this metrics explorer option, search for it, and here you can see the all the metrics related to the histogram. Okay, so you can get the count, max, or sum, or you can see the metrics in the form of bucket. So let's execute this. So let me clear this first, and let's search again. So you can see all the metrics in the form of bucket, and this is the upper bound of each bucket, and in the particular bucket this is the value for the matrix. Now what we will do next, we are going to see all these metrics in the Prometheus UI. So let me open the Prometheus. So URL will be localhost:3000. So username and password will be admin. Let's log in. So we will not reset the password, just keep this step. Okay, so here we are going to first see the configuration for the Prometheus. So if you click on this menu here and click on the data sources. Okay, so this is the configuration created by that data sources.yaml file. So if you click here, you can see it is mentioning the Prometheus server URL, that is Prometheus:9090. And in case you not created the data source.yaml file in your application, in that case, what you can do, you can create the configuration manually by clicking this add new data source option here. In that case, you can select the Prometheus. You will need to add URL manually and click on this save and test button. Okay, so let me delete this now. So we have already data source for the Prometheus server. Now what we'll do, we will add the dashboard to see the metrics. So we are not required to create dashboard from the scratch. There are already dashboard available in the market. So let me go into the Google, search for the Grafana dashboard. And let's open this Grafana lab link. And here you can search the dashboard. So let me search for the Spring. So click on this and click on this copy ID to the clipboard. So let me go into the Grafana and just go into this menu option, click on the dashboard, and here click on the import option. And here you need to copy that dashboard ID. Click on the load, and here you need to select the data source. And this is a default data source that we have added. And click on the import. Okay, so this is a dashboard for our application. Okay, so you can see the name of our application here. In case you have multiple application, multiple name will appear here. So this is a instance URL that we are going to monitor. And these are the some metrics we are getting by default by the actuator endpoint. Okay, so you can see it has a CPU usage, then the heap usage, your garbage collection details. Now, if you reduce this time to 5 minutes, you can see metrics in the more detailed format. Now, what we are going to do, we are going to create the dashboard for our custom metrics that we have added in our REST controller. So let's try for the first metric that we have created in our application. So in the test controller, we created first metric that was counter metrics, right? And here, just click on this dashboard setting icon, click on this make editable, and just save this dashboard. Okay, close this, and you can see one option is enable here. So click on the add, click on the visualization. Okay, so here I am adding a new chart in our dashboard. So here multiple options available for your charts. So first we'll try for the time series one. This is a name for your chart. So I am giving name as a visit counter example. Then here in the data source, I am selecting a Prometheus as a data source, which is our default data source. So from here, you can search the matrix name. So our matrix name was visit underscore counter, right? So this was a matrix sent by our application, and just click on this run queries. So you can see a graph for your matrix. So what we will do, we will change this matrix and we will use the query functions written by the Prometheus. Okay, so click on the code here and let me change this query a little bit. So I am using a rate function and I am adding window for the monitoring. Now let me explain this query. Okay, so what this query will do. So let's understand what this rate function will do. So this rate function calculates the per second rate of a change of the counter. And what is this 5 minute? So this is a time range or window which specify for the rate calculation. And as a summary, what this overall query will do, this query will calculate the average rate of a change of the visit counter total per second over last 5 minutes. So let's execute this query. So it is not showing any metrics currently. So let's execute that API again. Okay, so let me call this API for multiple times and let's refresh our chart here. Okay, you can see it has got the spike. So this is how you can create the chart in your dashboard. And if you select the different chart type here, it will show the different graph here. So let's select the time series and click on the apply. Now it will appear into the main dashboard. Now next what we will do, we will add the chart for the histogram as well. So let's click on this add, click on the visualization and let's search for the matrix. So matrix name was, so let me copy the matrix name. So matrix name was HTTP request histogram example. So here search for the matrix. So there are multiple options available. So we are interested into the bucket. Okay, so now it is giving hint to add the histogram underscore quantiles function. So it will calculate the quantiles for the particular bucket. So let's click on this add histogram quantiles. Okay, so it has already added the function by default with the 0.95 quantiles. So let's change this to the 0.25. And now if you want to see what it has created, so this is the query it has created automatically. So let me explain what this query is doing. So this histogram quantiles calculate the specific quantiles. In our case, that will be 0.25, that is 25th percentile or median for a given histogram. So this 0.25 indicates the 25th percentile. Okay, now let's click on this run query here. Okay, so it will not show any graph here. Let's execute that API again. Okay, so let's call this API for multiple times. And let's refresh our chart. Okay, you can see there is one dot is appearing here. Let's execute again this API. Okay, so let's refresh this chart again. Okay, so based on data, it will show the chart. So let's give some name for our chart and save this chart. Okay, so this is our histogram chart. And in the same way, you can create a chart for other metrics as well. So this is how we can set up the dashboard in the Grafana. Okay, so what we did first, we first created the Spring Boot application. And in the application, we have created the custom metrics. Then we created the configuration for the actuator in which we define the particular metrics which we want to expose. After that, we set up the Prometheus and Grafana, and for that, what we did, we added this graph configuration, and this graph configuration is used by the Prometheus to discover the service, and it will use this target URL to monitor our application. Next, we have added data sources.yaml file. This is used by the Grafana to connect with the Prometheus server. Next, we have added a docker-compose.yaml file to set up our Prometheus and Grafana into the Docker. Okay, so that's it for this lecture. Thanks for watching the video.